Hello everybody, this is Sudha Jamthe and this is the Internet of Things show. We have an exciting lineup today and I'm looking at Periscope here and I have people in Periscope. Hello everybody on Periscope, we're just getting started. We have a topic set as biometric sensors, and the world of sensors always fascinated me ever since I started digging into IoT, because that's the real foundation of this whole movement of IoT. So we have two speakers today. So what I'm fascinated about is sensors come in all ranges and they cover so many things. And so there are two speakers today. One is David. Hello, David.
Hi, Sudha. Thanks for having us.
And here is Karsten.
Hi there. This is Karsten. Nice to meet you.
So Karsten is joining us from Germany, and David is joining us from Seattle, and I'm here based in Silicon Valley. So as usual, we have an awesome global show. So what I would like to cover today, first let me get started with introducing our speakers, and then we can talk about the power of sensors and see what is different between sensors, whether they are in wearables or whether they are in industrial. Is sensor just another piece of hardware and it's all about pulling data from it and doing something awesome? Is that the world of IoT? Or is there more in taking a sensor and building a product out of it, or deploying it in an industrial setting? What is involved? That's what I would like to demystify today. Okay. So first let me go to David. Oh, I see a beautiful t-shirt thing behind you. Okay. Tell us a little bit about yourself, not just your company, but yourself and your passion for IoT and who you are.
Okay. So my name is David Vigano. I'm originally from Italy. Spent many years at Microsoft working on different 1.0 products, from MacWorks 1.0 and Mac Office 1.0 to all the way to Health Vault, which was my last baby at Microsoft in 2010, which was actually a cloud-based system that connected a lot of medical devices to the internet. So that was the early stage of IoT. We had about 2 million patient records in there and about 450 medical devices connected to it. So what we quickly realized...
This was from Microsoft? This was done at Microsoft?
It's still, yeah, Health Vault is still at Microsoft. Microsoft is figuring out what to do with it now with Azure, I'm sure. That was built before Azure. So it's interesting to see. And, you know, that kind of sparked our imagination to start Sensoria, because there was very little data coming from medical devices. People don't use medical devices. They use it for just a limited amount of time. So we kind of came out with the idea that why don't we actually embed sensors into whatever people wear, so we don't change the consumer workflow. We all wake up in the morning, take a shower, put our clothes on. Interesting that you see our t-shirt here has heart rate monitoring sensors embedded into it. They're transparent. So we think that transparent computing is what these new sensors are going to enable. So as a developer, I can build applications that were never possible before. That's, I think, the key of this new era of Internet of Things and sensing technology, truly wearable sensing technology. We call it transparent computing.
See, wearable has been around for a long, long time. I remember I used to be based in Boston a long time back, and I remember seeing, you know, some stuff in MIT where they were talking about wearables and wearing these gears with, you know, the sensors on their body long time ago. So it was not yet, you know, consumers were not quite ready, and we didn't have the sleek looking t-shirt. I mean, I would wear that.
Yeah, that's exactly the point. In fact, Sudha, we totally underestimated the challenge when we started. We went to MIT, we went to all the usual suspects, and we asked them for their material. So the problem is that there is a chasm between the research and the manufacturability, right? So we had to go back to the drawing board and create our own sensing technology. The one that we use for our smart socks, as an example, we created from scratch. You can actually see these are actually sensors, but you can't really see them because they're woven and knitted inside the sock itself. They're super, super soft. They're washable. So yes, it can be done. But it's still a lot of work. So that's where we are right now.
I want to come back. I want to come back to this because I have, you know, I have so much to ask you about. So hold that thought, and I want to come visit your socks because I saw the demo of your socks, how you run with the socks in your website, and that's what attracted me to actually connect with you guys in the first place. So all the thought, I'll be back. I want to hear a little bit about Karsten. Okay, sorry, I'm just bringing Karsten. Tell us who you are and how you got into this world of sensors.
Yes, hello from Berlin today. Hello from Berlin today. My name is Karsten Königstein. I founded a new company beginning of this year, focusing purely on industry manufacturing. So this is a different world, what you see there when you are talking about sensors. So I show you what sensors can be. This can be a sensor, and it can do temperature and pressure. And an industry sensor looks more like this one. Yeah, it's cased and it's against dust and water. It has heavy conditions where it is being used. It's more boring than what Davide is doing, but still it has some nice topics. Yeah, there is a lot of standardization going in and about the sensors in the manufacturing area. So there are standard adapters, what makes it more easy. It's called M12 4-pin. If you have this, then you can connect to almost 60,000 different sensors from the suppliers that deliver this, because there are some well-established suppliers. So you don't have to build this again. You can buy it. But what happens then? Because the sensor itself and the data coming from it is not much worth. Yeah, you have to derive some information out of the data you will receive from the sensor. But there's another topic, and in industry and manufacturing, there's always the topic about how to save money and what does it cost. It's very sensitive to this. Yeah, it's not emotional like in wearables. Yeah, people that buy Nike shoes, they tell them how far they run, and if it costs $100 more, nobody cares. In the manufacturing area, $100 is a lot of money, even you don't think so. And you have to think even a bit different. I made the calculation because everybody is talking about 50 billion devices. Yeah, if you make a calculation with 20 billion devices and what it costs to keep them running, and if you only assume these 20 billion devices consume 5 watts of energy, it's not much. Yeah, think of 5 watts. A pure Raspberry Pi uses 2 watts without any connections. So 5 watts is nothing, yeah, with all the data transmission. Then you need 50 coal power plants additionally to get these 20 billion devices up and living, yeah, just for connecting data. So there must be a use case for it, and we are very much about use case. We are not so much about emotional things like Davide. What is very exciting about, in fact.
So here we are talking about IoT and industrial sensors. The industrial IoT in general is going to save so much energy. You're telling us how much energy we heat up. So the value is more than that, more than what is created.
Yeah, it's about energy, it's about use case, it's about cost, very sensitive. Companies are very sensitive to cost in the manufacturing area, and they really need a use case and a business case in order to use products and to build in more connectivity and more sensors. Yeah.
So I want to go down to the basic, because for me, once I got attracted to IoT and I wanted to understand stuff, I looked at the nest in my house and tried to understand the sensors. Initially, I thought I had a very naive thinking. I just thought, how many sensors are there, right? And I could, so I came from an engineering background, and so I thought, okay, they were all, I looked at the heat sensors and said, oh, they were mechanical, and then they became electronic, and so I see the difference. And so now why they created the time series of data that the previous thermostat could not do. I get it. And then I went down the list of, okay, what other sensors are there? So I played with the standard sensors. There are these Texas Instrument sensors, the whole batch that you get, a bunch of sensor drones and all that. It gives you a standard list of 7 to 8 sensors. But if you try to do something meaningful with it, first of all, the data is not clean data that you can get it and interpret it. And then if you're talking about industrial strength, right? For industrial. If I try to do that for gas sensing. There's so many different sensors and different levels which I have checked for gas level. So it goes to a totally different domain. So I want to go to the wearable side because I do wear my heart out, and I was attracted to the socks because I get leg and I don't know WWS has a whole bunch of stuff, and I don't know how to actually make a socks and tell me, okay, I can get you information. Let's start with how do you pick the sensors? Did you go through a process of learning exercise, or did you end up making your sensors? Tell me more about what got you from making the socks as an example, or you can take any of your other this. You have a whole bunch, right? You have t-shirts, you have bra, you have a whole bunch of stuff with our sensors. So go for anything with my socks.
The way we selected, I think the way we selected the sensors, and I'm not sure if you can hear me now because
yes,
I feel the question. Okay, but it's very simple. We have a few tenets that we look at. The number one tenet for us is the sensor has to be comfortable, it has to be washable, and it has to be thin. The last tenet that we have, of course, is it has to be easy to embed into a piece of garment. Because when you wear a sensor on the human skin, of course, it has to be compliant to all the things that I just mentioned. If it's not washable, it's complicated. If it's uncomfortable, it's complicated. If it's not thin enough or embeddable enough, it disrupts the manufacturing process, which is what Karsten was saying before. If you add complexity and cost to the manufacturability, then the products that we come to market with have a price threshold that is way too high, right? So we don't want that, right? So we are very, very pragmatic when it comes to sensor selection. The sensors that you see here in our T-shirt, they're actually electrodes, more properly, they're not sensors. We license them. We did not create them. We could actually use textile sensors or polymeric sensors that are compliant to the things that I just mentioned. So they're comfortable, they're washable, they're thin, they're comfortable. But when it came to pressure sensors, we couldn't find in the industry something that was compliant with the tenets that I just described. So we had to go back to the drawing board and create our own textile sensors that can detect pressure. We're very open as a platform.
You created your own pressure sensors.
Yeah, we had to go back to the drawing board and we, from scratch, created our own textile pressure sensors. I know it's crazy, but we're not a very traditional startup, right? But the point is, it can be done. And the only way to show the industry that it can be done is to do it, right? So we're builders. So we built one. So now the sensor industry is waking up and saying, this is possible. This can be done, right? So now think about actually having textile, comfortable, washable temperature sensors, humidity sensors. If we could actually embed this type of sensors into whatever we wear, we can actually disrupt not just the sports and fitness industry, but again, also the medical device industry, right? Because unfortunately, each consumer becomes a patient from time to time.
David, it's fascinating to see that you guys actually made your own sensors for wearables, especially when you started with pressure. I heard recently that there is a French company, I forget the name, I should know it, which actually has made RFID embedded in the yarn, and you can you can wash it.
Great.
That's
and then now you see, I'd love to talk to them because it's not about the sensor itself. The sensor is a necessity, right? And the sensor has to be thin, washable, and comfortable. And of course, it has to be easy to manufacture at a reasonable cost, as Karsten was saying before. But the challenge here is not just the sensor. The challenge is to create something that the user, very much Sudha, you said before, I would wear this thing, right? So it's something that is communicating to others who we are, because that's what the garment is. We wear something that communicates who we are, right? So we don't want to actually wear something that is clunky or weird. I mean, it's most of us at least, right? So that's important. And then the last but not least component of the architecture is the cloud-based and mobile infrastructure. What do I do with the data? How do I convert that data securely into something that is meaningful for someone that is wearing it, right? Because at the end of the day, I'm not a data geek. I want to know what the data means in real real time, right? So those are three components of the architecture: the sensor, the garment with the embedded sensors and electronics, and the cloud system that can serve these new user experiences in a meaningful way for the consumer.
Perfect. So I want to revisit the cloud and the data part. I love the data. I mean, that's what I worked in eBay, focused on data, right, on the e-commerce side. So I do love it, and I think that drives your product experience. It tells you a lot more about customers. I think every point of data is something the customer is talking to you. You listen to it, you can build awesome products.
Absolutely.
But how do you get from a different world, right? The IoT world is several steps, right? So there's somebody wearing the garment and moving around, and then there's time series of data, and then how do you filter it, get the noise out, and get the real data, and how do you present it, and what do you do with it, right?
So let me give you an example. Let me give you an example of that. If you download the Victoria Fitness application right now, we have a database of 8,000 running shoes into that mobile application. So if you start wearing our socks and compare shoes, we can tell you how many miles you have run with each pair of shoes. We can tell you, oh, you're faster with this shoe. Oh, you're not off cadence with this shoe. Oh, you don't heel strike with this shoe. This shoe is a better shoe for you in a quantified, data-centric way beyond color and style. So think of this as, Sudha, you know this because of your eBay experience. This is a quantified shoe shopping experience which has never been enabled before. Now I can pick shoes at the right time and depending on my biometric data, not just on color and style, which are important, don't get me wrong, but I also want a shoe that minimizes my risk of getting injured and improves my performance. Not just I like the color, I like the style, right? So we think of this as a quantified shoe.
I like the color part is very important. That's where the emotional piece of shopping comes in. But then once I do that, I love shoes. And when I pick them, it's that emotion that's different, right? And then they say, oh, this is memory foam, it has all this awesome stuff, and I buy it. And then when I try it on in the store, it looks like it's all right? When you start using it,
you don't wear it anymore.
It's and pains, and I don't know whether I'm to my attribute to my shoes. So I could talk about shoes and what you're doing, for hours. But your point about the sensors, you had to go build your sensors as soon as we. So let's switch to the industrial side of it. Because when you say pressure sensors, the typical thing is industrial, right? So I want to hear Karsten's thought. Karsten, you had mentioned that you had the interface to 6,000 or 60,000 sensors?
60,000 different sensors. But in industry, we have another challenge. Yeah, we would love to collect the data and make these analytics on top of it. Yeah, there is a thing that is called predictive maintenance, what means the machine tells you in advance before it will break. What is cool, but you need a lot of data for that. But no company, and I can tell you, no company likes their industrial and manufacturing data in the cloud. This is the challenge. Yeah, so you cannot do it the conventional way. You have to do it from the manufacturer side of the machines, of the motors, of the actuators, or whatever, and they have to implement this as a set of rules, what finally gives you the indication that the machine will break. So it's really hard to get sensor data into the cloud from the manufacturing side. This is, unfortunately, it's not a technical issue, yeah? It's a mentality issue. Because
so the machine, sorry, help me understand this. So I've heard this predictive maintenance is in a factory setting, something could break, or in an airline, in parts in an airline, something could break, and in a plane, something could break. And before it breaks, your sensors are going to say, hey, it has hit, so this is the data I'm seeing that it's going to break. Right?
Yeah, in fact, it's not one sensor, it's a set of sensor, and in connection of these data you will receive, you will know that this setting of values will give you the indication that it will break. Yes, you're right. And this is really cool.
So and what is the mentality part? The manufacturers don't like to, to agree that their machine will break at some point?
Oh, no, it's not a problem about this machine will break. Everybody wants that, yeah? And almost nobody has it because they are really shy to give their data to the cloud. They are really shy sending any data to the cloud. They want to keep everything in their private data center.
Okay.
Yeah, because they have the fear that someone else will find out at what cost they are producing. That's the idea behind. So they don't like to see their sensor data in the cloud, where they cannot make that much sense of the data because it's a big data approach what you do there, and you need to understand from a lot of machines the indications what will lead to a failure. Yeah, and it's not one machine where you can derive it from usually.
So it's if a particular manufacturer would know about know data from all the different machines, they can make collective sense and predict better.
Yes.
Than so if it is a factory setting, say it's an assembly line of Boeing itself, right?
Mm-hmm.
And their own machines, they would be able to collect only that set of machines, not all the machines of that particular manufacturer. That's the problem.
That's the problem, yes. Yeah, and there are thousands of actuators of the same kind in different kind of industries, and it would make so much sense to collect this data and make sense out of the failures and predict the future. What is not possible because you are not able to and not allowed to collect these data. Yeah, only within one factory, and you only have 5 or 10 or 20 of these actuators of the same kind. So it's much more complex to do any predictions in this area. We cannot make a choose for shoes like David. Would be cool, but yeah, it's harder, and it's a lot of convincing you need to do in the manufacturing area still.
So when you say you have a solution that connects, so what you offer, what is your product called?
Oh, it's called Synfosy, Sensor Information System.
Sensor, I knew it was an acronym, Sensor Information System. You actually have, you connect to, so you have a software layer that connects to 60,000 different sensors.
That's correct.
So are you solving for the big data problem of, there are different kind of sensors, different interface sensors, you're just normalizing that to one data stream that can be manipulated?
Yes, okay. I'm normalizing to one data stream, and in fact, my development platform for the Internet of Things is Android, because you get very cheap devices with a distributed software update and everything. You get everything, notification, you get SMS and emails, all included what you usually have to program. So this is really cool platform, and it will be Brillo, I think, in the future on Google. What will be there? But for the moment, it's Android. It's my development platform.
So going back to what David said about, there are sensors that don't work for him, and he had to go make his own sensor. He didn't set out to go make the sensor. He set out to make cool clothing with existing sensors. Now he's expanded up the chain. Obviously, it's good value for his startup because he's successful in it.
Sure.
But that doesn't look like an easy thing that anybody can just go off and make it. Like when I hear about wearables, it looks. I've taken classes along with my kid on building wearables, right? Mm-hmm. And you wear it. I mean, I was at the Mini Makers Fair in San Jose this weekend, and there was this company who gave us, this was for little kids. They gave us a bunch of circuits, and it was actually all the different components. They gave us tweezers because it was in so tiny transistors and capacitors, right? But they gave us tweezers and a little soldering glue. And they made this little cute thing. I was hoping I'll keep it here in front of me, but it's not important. So, but everybody could just wear it as a necklace, and it had this blinking LEDs, right? So for us as outsiders, when we look at it, it looks like making these things is a piece of cake, and maintaining it just blinks. And I just, you could put that inside your shirt pocket, and here I have I have lights in my pocket, right? That's how I look at David's sensor when I look at the socks, and I think I'm oversimplifying. So tell me, what is the challenge in picking the right sensor? And I want to hear it from the industrial setting, and I want to hear it from. So let's hear first industrial. Pick sensors. What are the challenges? Why 60,000 sensors?
Yeah. When I did this predictive maintenance topic in the back, we have to find out which signals are relevant for a machine failure. So you run a machine until it breaks, or shortly before it breaks. And you need to get the right sensors. If you have an experienced machine operator, he knows and he hears and he feels when the machine will break. And you can do the same thing with sensors. So we put in the beginning a lot of sensors, any kind of sensor you can think of, oil quality, vibration, temperature, pressure, whatever you can think of is out there. You use in order to find out the right sensors that give you a signal that the machine will break in the future. And then you can reduce the sensors when you have found the right algorithm, what you can implement. So we worked this way. So we did it, I would say, trial and error, put everything on there, find out the right sensors, and remove the rest, and you are fine. This is how we did it. And as we can connect to almost any sensor that is out there, yeah, we went this way. This is a trial and error approach. It can be more scientific, I'm pretty sure. But the sensors are out there. Yeah, you can buy them from stock of many companies. Yeah, like Turk, Pepper and Fuchs, IFM, whatever is out there as big companies, multi-100 million euro, just selling sensors. But it's industrial sensors, nothing that Davide can use in his fabrics.
No, and then you have Davids of the world who are making new sensors, saying if all the 60,000 out there is not good enough for him. So,
true. Yeah, it's absolutely true. I think the world of sensors will double in size in the next 5 years. You know, the sensors that Karsten is working on, and he's fantastic. He's actually working on combining and making sense of the sensors we have in an industrial world. What we care about is the consumer world, and the consumer world doesn't have the right sensors because the industry as a whole, and Karsten knows this really well, has not focused on instrumenting the consumer, right. the human body. We have been instrumenting our cars for over 100 years now, right? So the sensing technology and the buyers of the sensors have always been different from the consumer. So when you say that you went with your kids to a maker's lab to make an LED light blink, we can make an LED light blink. Cornell University showed that with a piece of cotton, right, with yarn. So if we can replace traditional conductive material and sensing technology, so that will generate a new breed of sensing technology that is non-traditional, right? And that non-traditional breed of sensors will enable scenarios that have never been built before. Now, if you combine the pressure that Apple and Samsung are putting on their supply chain, that's why you need a microscope and teeny tiny soldering devices to actually put these pieces together, right? So by combining the microelectronics that are becoming cheaper and smaller every day with non-traditional sensing technology, we can make wearables disappear into whatever we decide to wear. And that, I think, is what is exciting. I mean, you can actually see we have a full SDK, so if you're a developer, you can actually build your own wearable garment, smart garment, using both traditional electronics, like the ones that we use into our anklet, we call it. So think of this as a Fitbit for the ankle. It's truly flexible, it's magnetic, so you can actually connect it to any piece of garment without breaking it or creating problems for that. But then the garment itself has additional sensing technology that augments the accelerometer technology, the gyro technology, the temperature or GPS technology that we have in our phone or in Fitbit-like anklet devices like this, right? So we can actually expand the world by creating new sensing technology that is truly wearable.
Fantastic. So we are almost coming to the end of our show. I wish I had more time to talk to you. I think I have more questions, and I feel like we've barely scratched the surface with this topic. So tell us a little bit on the cloud side, and then we'll wrap up. So David, what was your point about what you did on the cloud with it? I know it is not justice to all that you do, but you said you take this data out to the cloud.
Yeah.
There's so much data, and
yeah, we create. You're absolutely right. We generate as a human being. We generate a lot of data. We simply don't capture that today. If you think about our socks as an example, Sudha, we create data sets that relate to human locomotion. The Germans and the Italians had defined gait as the science of human locomotion, GAIT, in the mid-1600s. But it's 2015, and we still don't have a real-time, real-life tool for doctors to detect gait. post-stroke for a runner, for anyone that really wants to actually detect and collect this data. There is very little out there, and that's why we created the socks, and the socks actually collect gait-specific data if we wanted to. Right now, we don't have a medical product in the market. We have a consumer product in the market, but that could be done. In the future, that could be done, right? So that is what excites us. It's not just creating data sets that have existed for years, like the heart rate monitoring data sets that have been there for 60 years. Doctors know what to do with them, right? The researchers have analyzed this data. They can do predictive analytics now on this type of data, like we discussed before. Gait, there is no data, right? So that's why we selected the SOC, and we created a database in the cloud where, as a developer, I can use an SDK which is far more advanced than just the sensors plus Arduino. So I can actually come to market with a solution that in 90 days instead of 3 years, right? That's really the key focus of the company right now. How do we enable an ecosystem of developers to build applications that are truly wearable, smart garment aware applications in the cloud?
So your SDK is freely available. Can people just go to your website?
It's available on our website on sensoriafitness.com. Absolutely.
That's fantastic.
Yeah, we support Android, iOS, and Windows. So we try to be totally open as a platform. And again, we embrace any kind of sensors, not just our own sensors.
So Karsten, I know you have a separate product that is for the cloud side of things, right? Once you collect the data and you have a whole service layer and all that. So
yes.
Tell me a little bit about it, and then we need to wrap up for today. Maybe I'll bring you guys back again for another round too.
Sure. I have this. Thank you. I have this synthesis side, what collects data and sets measure points and informs you. And I have another product called Skip. And Skip is removing the paper from the production, from these paper-based production boards where only you find old production data from months ago. And it digitalizes this and leads it to the smart industry area now. And it can also visualize the sensor data you usually don't see because it runs into some IT systems and you have to dig it out afterwards. You can make it visible immediately. What helps you to react fast in production? Yeah, what helps you to save costs? So there's an approach to go this way.
This is fantastic. That's our time for today. So I need to wrap up. But I think we've just barely scratched the surface of this world of sensors in two different worlds, and with each of you I see David creating a whole bunch of devices. I mean, you don't call them devices, right? They're just wearables, and there could be medical wearables. And with this path of creating sensors, it's so scary. I mean, I would like to invest in your company, David. And with Karsten, I think we've just started on, we keep hearing about predictive analytics and how machines will check whether machines will break in industrial, and there's money in it, but nitty-gritty of making it happen is a lot more complex, and you've just barely introduced us to it. So thank you so much, both of you. And we are there with this actually live streams on YouTube, and we'll be archiving there. We can post some comments there with some links. And maybe I'll see if I can wrap up and do a blog around it and get more content from you. And David, I'll connect you with a French company which makes the RFID. Thank you, everybody.
Thank you, Sudha. Thank you, everybody.
Thank you for having us. Cheers.